So now that we've talked about how to visualize print results, let me show you the implementation, which will give you the ground truth of what it's really doing. This is actually kind of an interesting implementation. We'll talk about it in a couple different pieces. So if you recall, the purpose of this thing is to print the results of the word search. And this will, again, show off a couple of interesting Java features. First thing we do is we take the list of search results and turn it into a stream. Nothing surprising there. The next thing is more interesting, and this is going to use collect and grouping by. And this actually does a bunch of cool things. So what we're going to do is we're going to take the stream of search results, and we're going to convert it into a map. And the map's going to have each of the words that we search for as the key of the map, and the list of the indices as the value. So for each word, there'll be a list of indices. And this is actually really, really cool. And I'll show you this more when we talk about how to write your own custom collectors. But in a nutshell, what we do here is we're going to create a linked, first of all, what we're going to do is we're going to use the word, that's the method reference from search results, as the classifier. So that's going to classify the map so that the word will be the key. And then we're going to have the value be this thing that's created by the factory method to downstream collector. I'll talk more about that in a second. The linked hash map, remember when you use grouping by, you can indicate what type of map you want to have created. If you use to map, then by default you get a hash map. In this case, we did not want a hash map. We wanted a linked hash map. What the heck is a linked hash map? A linked hash map is a hash map, so it hashes the values and sticks them into the map using hashing. Surprise, surprise. But it also keeps a linked list of the order in which the elements were inserted. And that way, when we go to iterate through the hash map, the results will come out in the order they were inserted, even though, of course, a hash map distributes the elements all over the place in the map. So the map is scattered however it's scattered based on the hash function. But when you go to iterate through it, it will go through in insertion order. And the reason we do that is we want the results to be ordered when we print them by the do, re, mi, fa, sol, la, ti order that we inserted them. If we didn't use a linked hash map, when we iterated through it, it would show up with whatever order the hash spread the values throughout the map. So it's just a little bit more ordered, if you will. But it still uses hashing to actually do the computation. And then the third parameter here is a factory method that creates a downstream collector that merges the results lists together. So what's happening is here, we have a stream of search results, but what we're going to do is we're going to make a little collector that's going to merge all of the list of result objects that are in each of the search results into one list. And that's just a way to pare things down. And I'll show you that when we talk about how to write non-concurrent collectors. They're really cool. And then the last thing we do is for each element that came through here, in insertion order, we're going to go ahead and print the results out. And I'll show you print result in a second. And again, keep in mind that this is the maps forEach method, not the streams forEach method. And also remember, it'll be writing them out in insertion order. So here's what print result looks like. Print result, as you can see, is going to take a word, which is the key, and the list of search result objects as the value that's just passed in here. And it's going to print the word, followed by the list of search results. So there's a method called print results. You pass in a list of search results, it'll print it. And then the last thing we print here is the maximum indice in the list of search results. So I'm going to show you how to do that method in a second. And the main reason for doing that is to demonstrate map to int. So what we've got here is we have a list of result objects that's being passed in as the parameter. And a result object just keeps track of where the indice is. But it's an object, right? It's a reference type. So we create a stream of result objects. And then we apply map to int. Now, as we talked about a few minutes ago, map to int takes a stream of reference types and converts them into a stream of primitives. So what we need to do is we need to convert the result objects into an int. And the way to do that is to use the getIndex method reference from the result object. So what we're doing is we're taking the stream of result objects, only selecting whatever getIndex returns, which of course is an int that keeps track of the index. And so map to int is going to return a stream of int primitives, one for each of the indices in this stream of result objects. And then what we do is we apply the max method. And max is a method that's defined on an int stream. It's not defined on a stream. It's defined on an int stream. And what max does is it will return something called an optional int. I'll explain what an optional int is in a second. But basically what it's going to return is the maximum element in the stream. Or if the stream is empty, it returns something called an empty optional. We'll talk more about optionals. I think we've actually talked about optionals earlier in the class. An optional is just there as a placeholder to get rid of null values. So you never have to worry about something being null. If something isn't there, it comes back as an empty optional. So we get back an optional int, and if that optional int has a real value, then when we do the or else method here, that will return whatever the max was. And if for some reason, if this was an empty stream, which it's not, but if it were, then we'll give it a default value of 0. So that's how you work with optionals. So you don't have to check for nulls. The whole point of using optionals is never have to deal with null pointers again. And null pointers have a long and somewhat storied history in computing because null pointer exceptions are very common. Yes, Gavin? It should come back as a regular int. And in fact, you can see that here it's int. Yeah, that's a great question. Because it's an int string, so it'll return an int. Okay, any questions about that? So that's just a quick summary of how to implement print results, and it gave us a chance to talk a bit more about map to int. And as I mentioned earlier, I strongly recommend you try to use map to int in your solutions for assignment 2 when you're basically converting things that require sums in the stream.